This is the video of the solutions to your February 27th AP Pre-Calc quiz. Let's look at question 1, part A. It says solve for x on the interval from 0 to 2 pi. So we only want solutions that are in between or including 0 up to 2 pi. Cosine of x equals -1/5. So if you're thinking about the unit circle and I look at cosine, so I'm thinking about the x coordinates in the unit circle, with a -1/5, this is not a value we're familiar with, meaning it's not going to be the angle that's a multiple of pi over 4, nor pi over 6. So I'm going to graph the 2 points on the unit circle that have an x coordinate of -1/5. That'd be right here in the second quadrant and right here in the third quadrant. Now, we should know that whenever you take the arc cosine of a value in between -1 and 1, that output has to be in between or including 0 up to pi. So if we have an arc cosine of a number, and this number here for x has to be in between or including -1 to 1, then we know this output will be between or including 0 to pi, which will be in these boundaries. So to solve for this, I'm going to take the arc cosine of both sides. Now, the arc cosine of -1/5 has to be in between 0 and pi. Here's 0 here to pi. That implies this value here represents the angle in blue. It's between 0 and pi, so therefore it would have to definitely be in between 0 and 2 pi. So this right here is one of the two solutions. Here's 0, boop, that's one solution, boop, another solution. There's two solutions in between 0 and 2 pi, and this right here is the one in blue. Now it's really cool. Some students do this. They think about this angle right here dotted in purple, and they know, oh, that's the arc cosine of +1/5. See, if this point is to the left from the y-axis -1/5, then this point right here is to the right 1/5. And this angle in purple is arc cosine of 1/5. It would have to be between 0 and pi. It's right here between 0 and pi over 2. Now this angle in purple, I need the answer to be the one in pink. So to go from this purple angle all the way around there, you have to add pi. So it's kind of cool. Some students will write down as their second answer, arc cosine of 1/5 plus pi. So again, arc cosine of 1/5 is this purple angle. You add pi to get the pink one. Now that's super neat. What most students like to do is they'll multiply this angle here highlighted in blue by -1. When they do that, they actually do get this angle right here in pink when they multiply by -1. So see this answer here? Multiply by -1, but here's the difference. Instead of going counterclockwise through the first quadrant into the second, if I multiply by -1, now this angle is negative. It's no longer in between 0 and pi because I'm multiplying by -1. So it goes all the way around here clockwise. That's what negative arc cosine of -1/5 would be. So the problem is this is a negative angle, so it's not in these bounds. So I have to add 2 pi to put it in bounds. Add 2 pi. So these are our two solutions. But if you don't prefer to look at this second angle pink that way, you could have gone with negative arc cosine of -1/5 and then add 2 pi to it. This would be a replacement for this solution. They technically are the same, but they look different. Some students look at this as being, you go to 2 pi, so if I start here at 0, you go all the way around to 2 pi, and then you take away arc cosine of -1/5 to go back this way. That's kind of cool. So it's 2 pi all the way around minus arc cosine of 1/5 gets you to that pink angle. So again, there's only two answers. I'm going with these two. Instead of the one highlighted in pink, you could go with this one instead. They actually are the same numbers, even though they look physically different. Part B, we're still solving for this equation here on the interval from 0 to 2 pi. Now I see sine squared of x. The first thing I want to do is I want to solve for sine squared x. The end game is to get x by itself. Of course, solve for x. But first, let's solve for sine squared of x. So I'm going to subtract 1 to both sides. So 2 minus 1 is that 1. Then I divide both sides by 2. Now this is the same thing as sine of x in parentheses squared. So I'm going to take the square root of both sides. And that'll leave me with sine of x equals plus and minus the square root of 1 over 2. Now I'm going to simplify this and write this as sine of x equals plus or minus 1 over rad 2. Now you might not think you're familiar with this value, but if we rationalize the denominator, if we multiply by rad 2 over 2, I'm just taking this expression and multiplying by the number 1, I'm changing the way it looks, we will get plus and minus rad 2 over 2. That you definitely should recognize. We're familiar with the angles that are multiples of pi over 4 that intersect the unit circle at these coordinates, x and y coordinates. So I'm going to graph the unit circle. I'm going to graph the points that we're all familiar with that have a y value of positive rad 2 over 2. That's right here and right here. This is positive rad 2 over 2. And then negative rad 2 over 2. So the directions at the top say to solve this equation for values of x in between or including 0 up to 2 pi. So here's 0 to 2 pi. I see 1, 2, 3, 4 solutions. That angle in purple is pi over 4. The angle in red is 3 pi over 4. The angle in blue is 5 pi over 4. And the one in pink is 7 pi over 4. Those are your 4 solutions to this equation here. All right. Part C. So I'm going to first solve for cosecant of x. I'm going to subtract 5 to both sides of the equation. I'm going to divide both sides of the equation by 2. So we have cosecant of x equals 1. Now I can rewrite this. The reciprocal of cosecant of x is sine of x, and the reciprocal of 1 is still 1. Now I'm going to graph the unit circle. Sine of x equals 1 because this is sine. We're looking at the y coordinate, just like the last problem. We're looking at the y coordinates of 1. That'd be this point right up here. So again, the directions at the top say they want, or I want, all the solutions between 0, including 0, up to 2 pi. So here's 0. I go to 2 pi. There's only this one solution in that blue color, and that solution is pi over 2. Part D. So I'm going to solve for sine of x first by subtracting 1 to both sides of the equation and then dividing by 3. Now, I'm not familiar with the angle that intersects the unit circle at a y coordinate of negative 1/3. I'm not. So the answer won't be an angle that's a multiple of pi over 6 nor pi over 4. So I'm just going to go and sketch the angles that intersect the unit circle at a y value of negative 1/3. That's right here and right here. These two y coordinates are negative 1/3. So from the x-axis, you're going down 1/3. All right, something you have to know is that whenever you have the output of the arc sine of x, it has to output a value in between or including negative pi over 2 up to positive pi over 2. Excuse me. So arc sine of x cannot output. It cannot output an angle bigger than pi over 2. So I have to take the arc sine of both sides. So I take the arc sine of sine of x, that is x. I have to take the arc sine of both sides. So I have arc sine of negative 1/3. Now at the top, the directions state that I want the solutions, I want x, the answers for x, to be in between or including 0 up to 2 pi. So I can see if this is 0 right here, I'm gonna go all the way around to 2 pi. Boop, that's one answer. Boop, another answer. There's 2 solutions. Now this is the angle in blue. But right here, arc sine has to output an angle between negative pi over 2 and positive pi over 2. That means this angle right here, arc sine of negative 1/3, is actually a negative angle. It's between negative pi over 2 and 0. It's in between negative pi over 2 and 0. It's right in here. So therefore, I need to add 2 pi. This is currently the angle in blue. It's not in these bounds, so I have to add 2 pi to go all the way around. If you want to look at it this way, think of 2 pi first. Ready? 2 pi. Whoop, all the way around. I just passed up the blue angle. But now I have to take away arc sine of 1/3. So you can do that. 2 pi minus the arc sine of 1/3, which is the same angle as this. It looks different. It's the same. So this is our blue angle between 0 and 2 pi. Now it's really cool, kind of like the last time we had a problem like this, the very first question. Some students will take the arc sine of 1/3. See, students know that if this y value here is negative 1/3, positive 1/3 is right up there. So this is arc sine of 1/3, but we want to get there. So currently arc sine of 1/3 would be in between 0 and pi over 2. It's up in here. And so it currently is a positive angle. And now we add pi to get there. So you could write this angle in pink as the arc sine of 1/3 plus pi. Another option, these are your 2 answers, that's it. But if you wanted to, this angle in pink, a different way of writing that solution. So if you're not really tracking or you don't like how I wrote that answer for the one in pink, what some students do is they take this arc sine of negative 1/3 and they multiply by negative 1. So they take arc sine of negative 1/3, which is technically this blue angle here, and they multiply by negative 1, which puts it here where the purple angle is. So instead of going whoop, that way, clockwise, we're going to go counterclockwise. And then we have to add pi to this. So negative arc sine of negative 1/3 plus pi could be another answer, or another way of writing this angle here if you want to. It's your choice. But there's only 2 solutions between 0 and 2 pi. Part E. So this is tangent, and when we see the tangent function, we think of the slope of the angles. And we should be familiar with angles that have a slope of negative 1 over rad 3. Those are angles that have a denominator of it's pi over 6, or denominator of 6. But it has to be those angles that are in the second and fourth quadrants. The slope here is negative 1 over rad 3. I recognize this angle in blue as being 5 pi over 6. And this one here I can write as 11 pi over 6, or negative pi over 6. All right, Now, again, I still want the solutions, that's what the original directions say, between the values for x be in between or including 0 up to 2 pi. So check it out. Here's 0. Boop, boop. 2, there's 2 angles between 0 and 2 pi. But as I taught you in class, we're going to make a hypothesis. We're going to have triple that number of solutions. We're going to have, we see 2 angles here, times 3. I'm expecting there to be 6 solutions to this equation. When we solve for x, we're going to have to eventually divide by 3, which is going to make the angles become smaller. So therefore, we're going to have more solutions in between 0 and 2 pi. So, yes, you could take the arctangent of both sides, and that would represent, the arctangent of this would be this angle here, and that would be actually negative pi over 6. But what I'm going to do is, I recognize that the solutions to this is 5 pi over 6 plus pi k. This is 5 pi over 6. To go from this angle to here is pi. From the pink one to the blue one is pi again, over and over again. Tangent of these angles will equal negative 1 over 3. But see this 3x here? I have to write 3x equals. So 5 pi over 6 plus pi k represents all the solutions if it was just tangent of what angles is negative 1 over 3. But I have this 3x here. So now I'm going to divide both sides of the equation by 3, or some of the students like it better when I say I'm going to multiply everything by 1/3. Rather than divide by 3, multiply by 1/3. So 3x divided by 3 is 1x. 5 pi over 6 divided by 3 is 5 pi over 18, or if you prefer to do this, 3 times 6 is 18. That's 5 pi over 18. 1/3 times pi k is exactly that. Now, k is an element of the set of integers. Since I only want the solutions between 0 and 2 pi, my answer won't have k in it. K is only if you want to solve and you want every answer possible, then you have to have some variable to represent the set of integers. But here I want the solutions between 0 and 2 pi. You're like, why do you keep saying that? Because our quiz right here had all these problems, and it said solve for x on the interval from 0, including 0, up to 2 pi. All right, so let's start listing our solutions. If k is 0, we get 5 pi over 18. If k is 1, I want to create a common denominator, so I'm going to multiply this by 6/6. 6 divided by 6 is 1. I'm changing the way this term looks. So I can see 6 pi over 18. So if k is 1, I have 5 pi over 18 plus 6 pi over 18 is 11 pi over 18. That's another solution. Keep adding multiples of 1/3 pi. That'll be 17 pi over 18. Notice this isn't even, it's not even 1 pi yet. 17/18 pi is almost 1 pi. And I'm supposed to go up to, but not including 2 pi. So I'm going to keep adding multiples of 6 pi over 18. That's what this is right here. So this is k equals 0. I get this value. K equals 1. K equals 2. If I plug in 3 for k, I'd have 18. If I plug in 3 for k, I'd have 18 pi over 18 plus 5 pi over 18 would be 23 pi over 18. You can see the pattern is the numerator is going up by 6 pi. I'm adding 6 pi over 18. That's what this number is right here. So that's 23 pi over 18. I'm going to add 6 pi over 18 again. I get 29 pi over 18. 37. Whoops, I'm adding 6 pi, so that's 35 pi over 18. Okay, look. 18 almost divides into 35 2 times. So this is almost 2 pi. Not quite. So if I add another 6 pi over 18, that becomes 41 pi over 18, which is more than 2 pi. So I have to stop there. 1, 2, 3, 4, 5, 6 solutions is what I expected, because from 0 to 2 pi, I see 2 angles, but I'm predicting we're going to have times 3. And I was saying because in this step here, when we divided by 3, we made this angle smaller. Instead of adding pi, we're adding pi over 3. We're adding smaller increments. So those are your 6 solutions to this equation. All right, part F. Okay, so I could take the arc cosine of both sides. My preference would be, though, to just graph this. I'm familiar with, when I see cosine, I'm familiar with an x-coordinate on the unit circle of -1. That's right here. This is the only coordinate on the unit circle with an x-coordinate of -1. And so this angle is pi. Now, my solutions are supposed to be in between or including 0 up to 2 pi. So from 0 to 2 pi, I see one solution in blue. But I have this 2x, just like the last problem was a 3x. This is a 2x. I'm predicting there's going to be 2 solutions to this equation. So I just evaluated cosine of what angles is -1. The answer to that was pi plus 2 pi k. So cosine of these angles would be -1. So I'm going to set 2x plus pi over 6 equal to those angles. And again, k is an element to the set of integers. I don't know if you noticed, but previously when we listed solutions, when it was a 1x, I didn't write the k. I didn't use k at all. I didn't write a general formula. When this was cosecant of 1x, I didn't do a general formula. Again here, sine of 1x, no general formula. I can see the solutions between 0 and 2 pi. There they are. It's only when the coefficient of x is no longer 1 when I started writing the general formula, because I know there's going to be multiple solutions than what I see right here. So again, this coefficient is not 1, so I want to write the general formula. My final answer will not be general formula, but it's going to help me list my solutions. So I'm going to subtract. I want to solve for x. I'm going to subtract pi over 6 to both sides of the equation. So this is 2x. This is pi, or 6 pi. 6 pi is 1 pi. Minus 1 pi over 6. That will reduce to 5 pi over 6 plus 2 pi k. Divide every term by 2, or multiply both sides by a half, whatever you want to do. Same thing. You get 5 pi over 12 plus pi k. If k is 0, we get 5 pi over 12. If k is 1, I'm going to create a common denominator, multiply this by 12 twelfths. I think you agree that 12 twelfths is the same number as 1, it just looks different. So this is still 1 pi k. If k is 1, I have 5 pi over 12 plus 12 pi over 12. That will be 17 pi over 12. If I let k equals 2, and so I add another pi to this, it'll be out of bounds. It'll be bigger than 2 pi. We want our answer to be in the bounds of 0, including 0, up to 2 pi. And so adding another 12 pi over 12 to this would be 29 pi over 12, which is too big. So it's only these 2 solutions. And I had predicted that. Between 0 and 2 pi, boop, just one answer. But I'm expecting a second one, because we're going to have to divide by 2 here, so these angles get smaller. Instead of adding 2 pi, I'm adding, when I divide by 2 here, 1 pi. All right, part G. I'm going to try to factor this problem. I see a quadratic, 2 cosine squared x minus cosine x minus 1 equals 0. I'm going to try to factor this. So 2 is a prime number. So if this is factorable, I'm going to write 2 cosine x here and cosine of x, because this product would be 2 cosine squared x. Now our constant here is -1, so that means in each of these factors it would have to be a 1 and a 1 but this product has to be -1. So one of these has to be a minus sign, and one has to be a plus sign. So I can see if I let this be -1, that'd be -2 cosine x. So this would be -2 cosine x, and this would be positive cosine of x. So if I were to distribute this, do FOIL double distribute? The first term would be 2 cosine squared x, that checks out. Then I have 2 cosine x times -1 plus cosine of x will equal that middle term. So this is checking out. And then 1 times -1 is 0. So that's how I prefer to factor this quadratic. Now you use the 0 product property. This product, if it's going to be 0, then one of these factors has to be equal to 0. So I'm going to set each of the factors equal to 0. I'm going to solve for cosine of x. I'm not going to need a general formula to find all my solutions because this is a 1x and a 1x. I don't need the general formula. And I want all the solutions between or including 0 to 2 pi. In case you just started watching the video now, you fast forwarded to this. That's what the directions say. Solve an interval from 0, including 0, up to, but not including 2 pi. There's no equal to there. So I'm thinking about the unit circle. This part here, I'm highlighting blue. Thinking about cosine of x, that's going to be the cosine x coordinates in the circle of -1/2. And we are familiar with these angles. These angles will be multiples of pi over 6. So this angle here in the second quadrant is 2 pi over 3. The angle in the third quadrant is 4 pi over 3. Now I have cosine of x equals 1. This is the only location. When I see cosine, again, I'm still thinking x coordinate. That was cosine, this is cosine. X coordinate equals 1. That's right here. Here's our angle. That is the angle 0. If I go all the way around, that's 2 pi. But remember, the directions did not have an equal to sign on the 2 pi. There's an x can equal 0, but x has to be less than 2 pi. So I do not want to include 2 pi for these solutions. I'll just only include 0. Alrighty. Part H. This problem is already factored. I love that. I'm going to use the 0 product. This product is 0. So I'm going to set each of these factors equal to 0. I'm going to solve for cotangent of x by adding 1 to both sides. Now, the reciprocal of cotangent is tangent of x, and the reciprocal of 1 is 1. If you're not sure how I'm getting that, your workaround is if you just multiply both sides of the equation by tangent. Tangent times cotangent of x would be 1, those are reciprocals, and the right side would be tangent of x. So you'd still get tangent of x equals 1, which is this here. Now, secant of x, I'm going to solve for secant of x by adding 2 to both sides of the equation. The reciprocal of secant of x is cosine of x. The reciprocal of 2 is 1/2. If you're confused on how I got this, you can multiply cosine of both sides of the equation. And cosine of x times secant of x is 1. On the right side, you have 2 cosine of x. If you divide by 2, then you'd get 1/2 equals cosine of x. It would all be the same. Again, our coefficient here is 1x and 1x. I'm not going to need to write the general formula. I only want answers between 0 and 2 pi. So tangent of x equals 1. When we see the trig function tangent, we should think slope. So we're familiar with angles that have a slope of 1. Here they are. These are multiples of pi over 4. Then we have cosine function. So we think about the unit circle and x coordinates on the unit circle with a value of 1/2. So between 0 and 2 pi, this blue angle here is pi over 4. The angle in the third quadrant, this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. That's 5 pi over 4. Now we're looking at the pink angles. This angle here is pi over 3. The cosine of pi over 3 is 1/2. And this angle here in the fourth quadrant is 5 pi over 3. So between 0 and 2 pi, there's 1, 2, 3, 4 solutions. Those are our 4 solutions there. Okay, part I. Some people are really tempted right now in the first step to divide by sine of x. But you need to first recognize that that says sine of 2x. So you want to use the double angle formula for sine. That's 2 sine x times cosine of x. That's the double angle formula for sine equals sine of x. Some students did that correctly, and then in this step, they divided by sine of x, which means you're going to lose all the solutions when sine of x equals 0. So you really shouldn't divide by sine of x here unless you set that equal to 0 and solve later. If you're so tempted to divide by sine of x, you should recognize that that's a common factor that the term on the left side and the right side of the equation have in common. So rather than divide both sides by sine x, I recommend that you subtract sine of x to both sides of the equation because you want to get these terms on the same side. And now we factor out sine of x. Zero, this product, it's zero product property. You set each of the factors equal to 0. Earlier I did some problems and I had k involved. That's because I wanted to write the general formula because the coefficient of x wasn't 1, so I needed some help to figure out all of the solutions. So again, this is sine of 1x. This is cosine of 1x. Easy peasy. I don't have to do general formula. And I want the solutions between 0 and 2 pi. So I'm going to add 1 to both sides and divide by 2. So sine of x equals 0. This is sine, we're thinking y coordinates of 0. That's here and here. So here and there, both these points have the y coordinates of 0. I'll go ahead and list those solutions now. So 0 is one of the solutions. Pi is one of the solutions. Now, if I go around here, that's 2 pi, but remember in the directions, I'll go back up, just in case you just started watching the video here, but it says that we can include x can equal 0, but it has to be x has to be less than 2 pi, so we won't include 2 pi. So for this problem here, we will not include 2 pi, we'll stop there. All right, now we have cosine of x equals 1/2. So again, cosine, we're thinking x coordinates on unit circle of 1/2, that's right here. And right here, we just had that in the last problem. So this angle here in red is pi over 3. We know that the cosine of pi over 3 is 1/2. And then the angle in the fourth quadrant is 5 pi over 3. So from 0 to 2 pi, not including 2 pi, we have these 4 solutions to that equation. All right, now we're going from solving to graphing. So this says to graph arctangent. Now, something you should already know about arctangent, you should know that the outputs of arctangent of x from early on is in between the range, the outputs are in between negative pi over 2 and pi over 2. So I'm going to graph right here the parent function arctangent of x. The tangent function, I just said tangent, not arctangent, but the tangent function has a vertical asymptote at x equals pi over 2. You know the tangent of pi over 2 is undefined. That vertical asymptote becomes a horizontal asymptote for the inverse. That's pi over 2. And then the tangent function has a vertical asymptote at negative pi over 2. The tangent of negative pi over 2 is undefined. So that vertical asymptote for tangent becomes the inverse's horizontal asymptote. Now you also know that the tangent of 0 is 0. The tangent of x has a point at the origin. If you find the inverse and you switch the x and y coordinates, you will still get this point at 0, 0. This is what the parent graph looks like of arctangent of x. Now, this is one shift. We're shifting this parent function down pi over 3. So this horizontal asymptote, the whole graph is going down. This horizontal asymptote is going to go down pi over 3. So if you need to do the math, but you do pi over 2 minus pi over 3, you will get pi over 6. If you take negative pi over 2 and you subtract negative pi over 3, the shift down, you will get negative 5 pi over 6. Some things to look out for. The distance between these asymptotes was pi. See how this pi over 2, that's negative pi over 2, that total distance is pi. This total distance, 5 pi over 6 and pi over 6, is still should be pi. Now see this blue point at the origin? Every point got shifted, but I'm going to focus on that point right now. Every point, but this point right here in blue, is going down pi over 3. So that's where our y-intercept is going to be at negative pi over 3. And I'm going to sketch the curve. It's going to look like the parent function, but everything got shifted down pi over 3 units. Now I want to find this x-intercept. So you know this x-intercept has a y-coordinate of 0. So I'm going to plug in 0 for y. Now I want to solve for x. What is this x-intercept? So I'm going to add pi over 3 to both sides of the equation. Then I'm going to take the tangent of both sides. This is the tangent of pi over 3. I don't want to write this down, but I'll say it. I'm going to take the tangent of arctangent. So imagine me writing down tangent of arctangent. That would go away, and you get x. They undo each other. The tangent and arctangent are inverses. Now pi over 3. That's this angle here. And we know that the slope, the tangent represents the slope of that angle, is rad 3. Whoops. So x equals rad 3. The directions say to graph when you graph, label all of the intercepts. So we've labeled the x and the y-intercept. All right. Part B. We could graph part B by transformations. And what I would do is I'd graph y equals sine of 3x. And then you shift that graph. You shift it left pi over 3. I prefer not to do that if I don't have to, but that would be what I would need to do if what I'm about to show you doesn't work out. So here's what I'm hoping for. I'm hoping that I don't have to look at the most basic graph and shift it. I'm hoping I don't have to do that. I'm hoping that when I find the y-intercept, I'll get a y-intercept at the maximum. Hopefully that'd be great. At the origin's good, or at the minimum value. That's ideal. If I get a y-intercept that's not one of those 3 points, then I'm going to have to take the route of graphing sine of 3x and then shifting it. I don't want to do that because that takes a lot of time. So I'm going to first find the y-intercept. I plug in 0 for x, and I get the sine of pi, which is 0. Okay, that's fine. I was hoping it'd be at a max or a min. The max value is 1, the min is -1. I was hoping that would be our y-intercept. Here's why. If I have a y-intercept of 1, when I go to the right, the graph has to decrease. That's my only option. I love that. If I have a y-intercept down here at the minimum, then as I go to the right, the graph has to go up. I love that. The fact that I have a point here, it's like, I don't know right now if the graph is increasing initially or if it's going down. That's why it's like, okay, fine. I wish it was a max or min. It's not. I'll deal with it. So what I do know is that exactly a half a period apart is the next x-intercept. So right here, not a whole period, but a half a period is the next x-intercept. And then a half a period from this is the next one, over and over again. So I'm going to figure out what the period is. And if this is 0, from here to here is half a period. From here all the way to the second x-intercept will be a full period. So if you guys remember, to find the period of the function, it's technically the absolute value. It's 2 pi divided by the coefficient of x, which is 3. See this coefficient of x, it's 3. And so the period is 2 pi over 3. That means from here all the way to the second x-intercept will be a whole period. A half a period. If I take half of 2 pi over 3, I would get pi over 3. So from x-intercept to x-intercept is half a period. From here to here is another half a period. So pi over 3 plus pi over 3 is 2 pi over 3. And remember what I said? From this x-intercept all the way here is a full period. This x-intercept over here would be negative pi over 3. And this one is negative 2 pi over 3. All right, so I'm not sure if the graph is going up or down. But you know what sine and cosine looks like. You know in between these two x-intercepts, there must be a max or a min. So this is great. See between 0 and pi over 3, that value is pi over 6. I'm going to plug pi over 6 in here, and I promise you, we better get out either the max value of 1 or -1. It has to be one of those two numbers. If not, we screwed up. So let's plug in pi over 6. And if we find out it's above, we're going to draw the graph increasing initially. If we find it's below, then we'll be decreasing right here, the graph. So in case we're not sure what's going on, I'm going to let x equal pi over 6. I plug it into this function for x. Oops. Okay, so I'm plugging pi over 6 in here for x. So I get the sine of, this is pi over 2 plus pi. Okay. Here's pi. That's pi. Plus half a pi, which is here. Maybe I should have done this. Pi over 2 is there, and you add pi, then you end up down at 3 pi over 2. The sine of 3 pi over 2 is -1. So we just figured out when you plug in pi over 6, the output's -1. That means the graph has to be initially decreasing as we go to the right of this point at the origin. The directions say to graph at least 2 periods. This is 1 period. Every 2 of these humps is a whole period. All right, so there you go. There's 2 periods drawn. All right, part C. Let's graph the parent function arc cosine of x first. Based on what we did a while ago, you should know that arc cosine of x outputs a value in between or including 0 to pi. That means this graph, arc cosine of x, must have a range from 0 to pi. Now, if you remember this cosine function, it goes up to 1 and down to -1. That's going to be our domain of arc cosine. So the range of cosine, I don't have cosine anywhere on here, but the range of cosine is -1 to 1, and that becomes the domain of this function. Now cosine normally has a y-intercept. Cosine of x does have a y-intercept at 0, 1. 0, 1 becomes this point right here. So the y-intercept of cosine of x, which is at 0, 1, becomes the x-intercept of the inverse. And then if you remember, the cosine of pi over 2 is 0. So cosine had an x-intercept at pi over 2. That means the inverse will have a y-intercept at pi over 2. This is what the parent graph looks like. You need to be familiar with that function. Now we're shifting this parent function to the right a half a unit. That's not going to change our range, but it will change our domain. So instead of -1 being the smallest value for x, if I shift this whole graph to the right a half, the smallest value will now be -1/2. This point, all the points are moving to the right a half, but this one in particular, this red one, I'm going to graph it. It'd be over here somewhere. And then to finish my earlier thought, the domain is -1 to 1. If I shift it to the right a half, this 1 plus a half will become 1.5, or 3/2. Oops. So this point, every point gets shifted to the right a half, but I'm focused on that right now. It goes right here. So I'm going to draw my curve like this. This point here, I'm going to label, because the directions say to label your endpoints. This is -1/2, comma, pi. The range is still 0 to pi. Now we need to find this y-intercept. So this point is 0, comma, a y value. The y value is somewhere between 0 and pi. So we're going to plug in 0 for x, because this x coordinate of that point is 0. So we plug in 0 for x to find the y-intercept. So we get the y-intercept is equal to the arc cosine of -1/2. So these are the two locations on a unit circle with an x coordinate of -1/2. Arc cosine has to output an angle between 0 and pi. So this expression is going to output this angle right here in orange between 0 and pi. And that angle in orange is 2 pi over 3. Alrighty. Arc sine of x plus pi over 6. This is part D. So arc sine of x, let's graph this parent function. We should know that the arc sine of x has to output values in between or including -pi over 2 to pi over 2. That's my range of arc sine. Now the sine of x, the sine function, goes up to 1 and down to -1. That's the range of sine of x. That's going to be our domain then of the inverse of sine from -1 to 1. Sine of x has a point at the origin 0, 0. So when you switch those coordinates, you still get the point 0, 0. This curve is going to look very similar to the sine of x. Make sure the concavity is correct when you graph these. It looks like it has the same concavity of the function y equals x cubed. So if you remember the function y equals x cubed, the point of inflection is at the origin, and then it's concave up and then concave down right here. So there's arrows on x cubed. For arc sine, don't put arrows, please. It's endpoints. But I just want to make the point that make sure the concavity of arc sine of x looks like the concavity of y equals x cubed. And I didn't mention it here, but the concavity of arc cosine of x looks like the negative x cubed function. Again, there's no arrows, those are endpoints, okay? It's only the arc tangent function that has arrows at the end. All right, so now this is gonna shift. We're shifting this parent function up pi over 6. So our range, instead of having a max of pi over 2, if you're at pi over 2 and you add pi over 6, you get the angle 2 pi over 3. So here's pi over 2, whoop, plus pi over 6 is the angle 2 pi over 3. Otherwise, create a common denominator, combine those fractions, it'll simplify to 2 pi over 3. Now, the distance between the max and the min is pi here as well. Same with arc cosine, it's pi from the max to the min apart. The asymptotes of arc tangent are a pi apart. So that should check out. So if this max is 2 pi over 3, the minimum would be at negative pi over 3 because they're going to be, the max and min will be pi apart. Or you just take negative pi over 2, you shift it up pi over 6, and you end up with negative pi over 3. Now every point on this curve is going to be moved up pi over 6. But I'm going to focus on that blue one for a moment. It's going to be right there at pi over 6. It was at 0, 0. Now if I'm moving the graph up, the domain's not going to change. It's still going to be negative 1 to 1. I'm putting my endpoint here and my endpoint there. Got to remember the concavity looks like negative x cubed. This is my final answer. So the directions say to label endpoints. This is my scratch work, so I didn't label those endpoints there. So here I want to label them because this is my final answer. So it's 1, 2 pi over 3. This endpoint is negative 1, negative pi over 3. But now we need to find this x-intercept. So to find the x-intercept, we have to plug in 0 for y. Now my goal is to solve for x. I'm going to subtract pi over 6 to both sides of the equation. Now to solve for x, I have to take the inverse of arc sine, which is the sine function. So I'm taking the sine of both sides of the equation. So that'd be sine of negative pi over 6. I don't want to write this down, but it would be sine of arc sine of x. The sine of arc sine undo each other because they're inverses. That composition would just give you this x here. Now, negative pi over 6. That's this angle here. And we should be familiar with this y coordinate. When we see sine, we think y coordinate. This y coordinate in the unit circle is negative 1/2. So we get x equals negative 1/2. All right, part E. I'm going to first sketch y equals negative 2 cosine of x. The range of this is negative 2 to 2. Because of this reflection, instead of having a point at on the y-axis at the max, it'll be at the minimum value. Now this 2 here is a shift up 2 units. That means instead of having a max at 2, it's going to be a maximum at 4. But see this minimum of negative 2? If I shift the whole graph up 2 units because of this shift up 2, negative 2 plus 2 is 0. So the graph will actually start here at the origin. If you want to check that, look, plug in 0 for x. That's what this value, this x coordinate here is 0. Cosine of 0 is actually 1 times 2 is 2. 2 minus 2 is 0. That's our minimum value. The graph is going to go increasing right here, decreasing, and then back down, and then back up. The period of this function is 2 pi. The period is 2 pi divided by the coefficient of x. If I start here at the bottom, at the minimum, and I get to the minimum right here, that is 2 pi. If I start at the minimum here and I go all the way back down to the minimum, that's negative 2 pi. Some people got those wrong. Now, if you want to solve for them, we can do that. If you want to find the x-intercepts, you can plug in 0 for y. We could technically do this for the other problem we had with sine. If you wanted to, we could plug in 0 for y here and solve that equation and label all these x-intercepts. So if I set this equal to 0, I'm going to add 2 cosine of x to both sides of the equation. Then I'm going to divide by 2. X equals 1 is right here. So we have 0. If I go all the way around, that's 2 pi. All the way to there is 2 pi. If I hit reset and I go back to 0 and I go clockwise, that's going this direction. These are negative angles when I go clockwise. I'm going to go to negative 2 pi, and that's right there. So that's our graph for part E. All right, evaluate the expression given cosecant of x equals 4 and cotangent of x is less than 0. This is saying cotangent of x is negative. So let's just change cosecant of x to sine of x equals 1/4. Because sine of x outputs a positive number, I know the angle x has to be in the first or second quadrant. I'm not sure which one, which is why I gave you this information. This basically says cotangent of x is a negative, less than 0. If cotangent is negative, that also implies that the tangent of x is negative. That means the angle x has to be in the second quadrant. Now I could draw a unit circle and put a point at a y value of 1/4, but I would prefer to draw a triangle here. Now I'm kind of getting ahead of myself before I show a need for this. So let's go ahead and take sine of 2x. And we're going to expand this using the double angle formula, which is 2 times sine x times cosine of x. Now, because cosecant of x equals 4, I know sine of x equals 1/4. Now this is giving me a need to find cosine of x. It's giving me a need to draw this triangle. So this is my reference angle, x here. The sine of x, remember SOHCAHTOA, the sine of x is the opposite side of the right triangle divided by the hypotenuse. If you find this missing side using the Pythagorean theorem, you have to square 4, that's 16. Subtract 1 squared, that's 15. This missing side squared equals 15. That means the missing side is square root of 15. That's the length of this, the distance of this base. But direction, if I start at the origin, I'm going left and then up to get to this point up here. So direction-wise, if I'm going left, this has to be negative. So here, what's the cosine of x? The cosine of x is negative rad 15 over 4. Now I'm going to simplify this. 2 times negative 1 times negative 15 is negative 2 rad 15. 4 times 4 is 16. 2 is also a factor of 16. 2 times 8 is 16. So I can cancel those common factors and get negative rad 5 over 8. That's our answer to part A. Part B, you have 3 formulas you could use for this one. We could use cosine squared x minus sine squared x. You could use 2 cosine squared x minus 1. The one I want to use is 1 minus 2 sine squared x. I want to use this one because I was basically given cosecant of x, so I found sine of x by taking the reciprocal. Some people found this value incorrectly, which means you're going to have cosine incorrect if you have this number wrong, which means if you use this formula here, that term will be wrong. If you use this formula, that term is wrong. But because cosecant of x was given, and I don't think I screwed this up, I am going to use this one right here to avoid any user error if I happen to make a mistake in doing this triangle. So sine of x equals 1/4. So I'm going to replace sine of x with 1/4. This notation is sine of x in parentheses squared. That's what that means. If I square 1/4, I get 1 over 16. Times this 2, that reduced to 1/8. 1 minus 1/8 is 7/8. If you need to have a common d, all right, great. 1 is the same number as 8 over 8. Minus 1/8, that is 7/8. If you use either of these 3 formulas, you should get the same answer of 7/8. All right, I hope this video helped you to understand some of these problems. I hope you do great on your test this week.